All right. Good evening. My name is Abiola Lawal. I am one of the participants of MicroMasters, which was organized by Ada Global Academy in person of Professor Olawale Hawe. So we're actually given a malaria data set to actually build and deploy a machine learning model. So so basically the the model and all of those things have actually been built. We just have to look at it, fine tune the model, and deploy it and see how the end users can actually do that. So that is the task ahead. So let me give us a background knowledge. As we all know that malaria is actually one of those key diseases that kills people in Africa, and this has been happening for a very long time. So there is this data set that was gotten. So we're asked to predict whether uh, the malaria is severe or not severe. So this data set actually consists of 17 features and a total of 337 rows. So under the target, our target variable is uh, the severe malaria column, which consists of 0 and 1. The 0 indicating not severe, and the 1 indicating that malaria is actually severe. So we actually want to say that we want to predict that, oh, malaria is severe, it is not severe. That is our end goal. Okay. Now, when you look at this data set clearly, we can see that um, directly from the data set, 66% are indicating not severe, while 34% are indicating severe. So another thing is on that same data set, we have a clean data set, that is the data set is clean. Then the feature type, so all are integer, so there is nothing like um, code encoding or imputation required. Okay, then so from the data set also, the top predictors are age, headache, convulsion, beta fung, and jaundice. So, like I said, our aim is not to actually build this from the beginning. These has actually been already known. So it's just to look at it and fine tune everything. So now, the first thing as a data scientist, the first thing you're supposed to do is to actually do what we call EDA. Just like we know that EDA is what we call exploratory data analysis, just to explore the data set so that we can understand what the data set is all about. So, so from this guideline here, we have loading and detecting the data. So the first thing is you want to supply all the libraries that we need. Okay, so let me just walk us through my own notebook that I was able to produce what the tasks I had. All right, so this is my notebook here. So on this import page, I have all the libraries that I needed for the task. And part of the library was I needed to import OS so that I can um, be able to store the model. I also have NumPy library, Pandas library, Matplotlib, the sklearn, that is for me to import the logistic regression, random forest, gradient boosting, and the support vector. So these are the models that will be used, And also I needed to import the standard scalar. The reason for using standard scalar is because um, some of the data, my target variable is in zeros and one, while the features are in different values. So I need to ensure that they are in the same scale so that the values will not be far away from each other. So I also have the metrics. So I needed to import those metrics. So we're looking at the precision, the recall, the F1 score, and a ROC score. Okay. Um, then I also have the pipeline because I want to build this in the pipeline. I want to put the standard scalar, the model, and all of those things in the pipeline. Because the reason of pipeline is because of data leakage. Okay, and then for the imbalance, you can see that the data set is imbalanced. We have 66% on one side and 34% on another side. So that creates an imbalance. So if I don't load the library for the imbalance, I'm already telling the model what to predict or what the prediction is going to look like. But with imbalance, that can actually generate a synthetic data just to balance the 34%. Okay, so I loaded um, my data sets, and like I said, I was able to have an overview of um, the data sets. So the reason for the standard scalar basically is for this age. You can see that the age is from 3 down to the maximum age here, while every other ones are in 1 and 0. All right. Now, so so all these are just trying to see, like I said, you can see that there is severe malaria 56% and the non-severe taking the other side. All right. So like I said at the beginning of the discussion, that age, uh, hypoglycemia, fever, headache. So these are the top symptoms for malaria. Okay. Um, so now looking at the correlation, so this is just trying to see how correlated are these variables. What is the predictive power? So we can also see that headache, hypoglycemia, cold, diarrhea. So all of these are actually um, correlated with predicting whether you have a severe malaria or not. All right, so now let's go down. So this part here is just trying to give us a summary of what the data set looks like. Okay, like I've explained earlier, we have class imbalance. Then we also try and check the relevance of those features, which I've also mentioned. There are also weak features that also exist in the data set. All right, so let's move to uh, separating our data. Our target variable is the severe malaria, that is what we want to predict, and our features are the other columns. Okay, and we needed to split our data set because uh, this is a supervised machine learning model, right? So we needed to split the data into X string, X text, right? So and I'm using the 80 to 20 percentage and the random states to be 42. Okay, so now, so like I said, we have four models, and the models are logistic regression, random forest, gradient boosting, and support vector machine. Okay, and from the like I said, the the all this model has already been built, and okay, let me just go down. Okay, now I also have the pipeline. So the pipeline is I want to scale first. So the reason why I'm scaling is for because of the age, then followed by the imbalance. There is imbalance in the data set. To create a balance, I'm using the smooth. Then lastly, come and build the model. So that is why I am having this pipeline. Then I also want to do a cross validation. So, and I have split of five. The essence of the cross validation is to split my data into five different folds, right? So when you are done with this, take the next fold. Also split it into train and testing, take the next fold like that. So at the end, let me have a cross validation score taken from the pipeline, right? The X train, the Y train, and the CV score. Okay. Um, so now, so going to the results. So for the logistic regression, I have my precision, the recall, the F1 score, and the AUC. Okay. So when we say precision is basically trying to tell us that for all the predicted outputs, so that is for all the predicted that was severe. So how many percentage were actually severe? That is what precision is trying to tell us. And talking about recall is just trying to tell us that for all the actual severe predicted, how many how many did the model actually detected? Precision, let me take it again. Precision, that is for all the predicted, like for all the ones that are predicted that are severe. So how many were actually severe? Now, what recall is trying to tell us that, okay, for all the actual severe patients, how many did the model actually detected? Okay, and the F1 score is trying to take a balance between precision and recall. So there could be instances where you're going to have a very high recall and a very low precision, or vice versa. So what the F1 score is trying to do a balance in between the two. Okay, so we are always looking for a higher F1 score. Okay, and lastly, talking about the ROC or AUC. So this is just trying to tell us how well does uh, the model separate severe from non-severe. So at the end, so this is also the confusion uh, matrix here. All right. So for the confusion matrix, let me quickly explain. We have the true positive. So the true positive is just trying to tell us this is the one out of all the prediction. This is the percentage that I was able to predict correctly. Now talking about false negative. So the false negative means that there were there was severe case. However, these are the numbers that I actually missed. So we want to try and ensure that we have a reduced false negative. Then we have the true false positive. So false positive has to do with is actually is wrongly flagging cases. Okay. Then we have the true negative. So the true negative is just the correctly predicted non cases. So like I said, we need to watch out, right? So we need to watch out for false negative because when false negative is higher. So our model is actually very, very dangerous. In the case of the model we are currently building, this is an health data set. So our margin for error is actually reduced minimal. So there is a table down here which uh, let me go down. Okay, so I have a table down here that is showing the F1 score, the recall, and everything at a glance. Now, if you look closely, we have for logistic regression, the precision is 33. That is, it's trying to tell us that it actually predicted 33% of those that were actually severe, while the recall is 65. That is, for for all the actual severe patients, how many did the model detected? So it detected 65%, right? Now the F1 score is trying to check the balance. We have F1 score of 44 and we have AUC of what? Of 61%. And I said AUC is trying to tell us how well the model separates severe cases from non-severe cases. Now we also have the random forest, we have the gradient boost, and we have the support vector. Now, if you look closely, the this SVM is the one that the model that I will go for. Why? Is because for the precision now, that means it's trying to tell us that 40%, let me just say 41% of the patient that were detected, right? It is detecting 41% as severe cases out of the actual severe cases. And for the recall, I have a recall of 55%. That is for all the actual patients, how many um the model detected. Then I have an higher F1 score. Out of everything, he is the only one that is giving us an higher F1 score. Like I said, we should look out for higher F1 score because it's the one trying to check the balance between precision and recall. Then talking about the ROC is also 61 percent. So that makes me to choose the support vector machine as the best model. Okay, so then after that, I save my model. So after uh, saving the model, okay, then I now try to check the feature importance of different model. So for the random forest, the most important variables are age, headache, convulsion, and protraction. Okay. For the gradient boosting model, right? I have things like age, convulsion, headache, and which is similar to what I have in the logistic regression model. So now, for for the sharp, so the sharp is just trying to also tell us, it's just trying to explain why I am using that particular uh model. So for the SVM, I actually use the dialects. So what the dialects is trying to also tell us that we we have a higher. Let me just go to this one here. Okay, good. Okay, yeah. So okay, so it's just trying to explain why the SVM was selected. So after evaluating all of them, Like I've said earlier, the SVM actually is actually the best because of the F1 score. So the petition made it practically useful. It makes it a one of the best classifier. Now, um, so from the question has, could we have added more data or additional clinical features to actually improve the model? Yes. So if we have added more variables, that would actually improve the the predictive power of our model. If you can see, none of those model actually scale through 65 or 70%. So it shows that if we add more variables, maybe like temperature, like some other things, maybe that would also help us to check whether it's severe or not severe. Then lastly, I deploy this model by actually creating a Git repository. So after creating a Git repository, I deploy it to the Git, then create a virtual environment for the Docker. So after creating a container inside the Docker, then deploy it on the Docker to actually make the app live. So we're able to get an API. So this is the code for the API. So let me just walk us to the API. Okay. Let me walk us through the API. Okay. Um, Malaria. Yes. So while that is loading, so this is for the Streamlight. Okay, this is still sleeping. Let me run it again. Okay, yeah. So I can literally supply the age, maybe 65 or 67, the gender, whether it's a male or female, is there fever, is there cold, we go fatigue, headache, biting from vomiting, diarrhea, convulsion, right? So I'm just putting this as a random. Okay, so let's run. So so with the information I supplied, so it's trying to tell us that it's not severe and the risk is low. Okay. So I think what is just there's a gap here. So the first gap is I need to go back and redeploy data to ensure that I convert this one and zero into yes and no so that they can supply, they can just click and say yes and no, and also ensure that my my prediction is also explainable. Why did you say that diarrhea or convulsion or anemia or vomiting, right? So I want to ensure that those things are actually showing in the front end, just to explain to the user why it's predicting with those particular variable. Yeah, thank you very much.